Hi dear students, in this video let us see the relationship between zeros and coefficients of a cubic polynomial. Before studying the relationship between zeros and coefficients of a cubic polynomial, first let us see the relation between zeros and coefficients of a linear polynomial and for a quadratic polynomial, and let us then go to cubic polynomial. A linear polynomial. The general form of a linear polynomial is ax plus b. We found its zero as minus b by a. Let us obtain this relation by forming linear polynomial with a 0 alpha. Let the 0 be alpha. Then how do we form the linear polynomial? The linear polynomial will be x minus alpha. There are infinitely many number of linear polynomials having 0 alpha. So the linear polynomial is k into x minus alpha, where k is any real number not equal to 0. So we have the linear polynomial as k into x minus alpha. Now let us compare this one with the general form ax plus b. Compare this with general form ax plus b. Here x term is a and here x term is k. So a is equal to k. And here the constant is b. So b is equal to, here the constant is k into minus alpha. So it is minus k alpha. From this, let us get the relation between alpha and the coefficients. From this we get alpha is equal to b by minus k. But here we get k is equal to a. So alpha is equal to b by minus a. This can be written as minus b by a. By writing the fraction in simplex form, we are getting alpha is equal to minus b by a. This is the relation for linear polynomials. Now let us see the relation for quadratic polynomial. The general form of quadratic polynomial is ax square plus bx plus c. Here a is not equal to 0. If alpha and beta are the zeros of quadratic polynomial, then we can form the quadratic polynomial as x minus alpha into x minus beta. X minus alpha is the linear polynomial corresponding to 0 alpha. X minus beta is the linear polynomial corresponding to 0 beta. There are infinitely many number of quadratic polynomials having zeros alpha and beta. So the quadratic polynomial becomes k into x minus alpha into x minus beta. By expanding, we get k into x square minus alpha plus beta into x plus alpha beta. Now by comparing this quadratic polynomial with the general form is ax square plus bx plus c. We get a is equal to k. Here x square term is a. Here the x square term is k. Now b is equal to minus k into alpha plus beta, and c is equal to k alpha beta. From this we can get the relations for alpha plus beta and alpha beta. Alpha plus beta, from here alpha plus beta is equal to b by minus k. Here k is equal to a. So alpha plus beta is equal to b by minus a. This can be written as alpha plus beta is equal to minus b by a. And here we have c is equal to k alpha beta. C is equal to k alpha beta. From this we get alpha beta is equal to c by k. Here k is equal to a. So we get alpha beta is equal to c by a. So alpha plus beta is equal to minus b by a, and alpha into beta is equal to c by a. Now let us see cubic polynomial. We can obtain the relationship between zeros and coefficients of a cubic polynomial in the same lines as we got them for linear polynomial and quadratic polynomial. The general form of cubic polynomial is ax cube plus bx square plus cx plus d. Here a is not equal to 0. Now, if the zeros of a cubic polynomial are alpha, beta and gamma, if alpha, beta, gamma are the zeros, then how do we form a cubic polynomial? The linear factors of the cubic polynomial will be x minus alpha, x minus beta and x minus gamma. So the cubic polynomial is x minus alpha into x minus beta into x minus gamma. But we have infinitely many number of cubic polynomials having zeros alpha, beta and gamma. So the cubic polynomial will be k into x minus alpha into x minus beta into x minus gamma. By expanding, we get up to here we know x square minus alpha plus beta into x plus alpha beta into x minus gamma. Now let us multiply the quadratic polynomial we got here and linear factor x minus gamma. X square minus alpha plus beta into x plus alpha beta into x minus gamma. What do we get? Let us see. First let us multiply by x. We get x cube minus alpha plus beta x square plus alpha beta x. Then by multiplying with minus gamma, we get minus gamma x square. Then here minus into minus is plus, plus alpha plus beta into gamma x, then minus gamma into alpha beta, that is minus alpha beta gamma. Adding the partial products, we get x cube minus alpha plus beta plus gamma x square, and here we get alpha plus beta plus beta gamma plus gamma alpha x minus alpha beta gamma. So the cubic polynomial we are getting is x cube minus alpha plus beta plus gamma x square plus alpha beta plus beta gamma plus gamma alpha into x minus alpha beta gamma. Compare this with general form. The general form is ax cube plus bx square plus cx plus d. Now to compare the cubic polynomial we have got here with the general form, we can multiply this with a to make the leading term as ax cube, or we can multiply with k. In both ways we can get. Let us say we are multiplying with a, then we are getting ax cube minus a into alpha plus beta plus gamma x square plus a into alpha beta plus beta gamma plus gamma alpha x minus a alpha beta gamma. Now comparing it with the general form, we get a is equal to a, so this we need not consider. Here b is equal to minus a into alpha plus beta plus gamma. C is equal to a into alpha beta plus beta gamma plus gamma alpha. D is equal to minus a alpha beta gamma. Now let us take the relationships. Alpha plus beta plus gamma is equal to minus b by a. Alpha beta plus beta gamma plus gamma alpha is equal to c by a, and alpha beta gamma is equal to minus d by a. So this is sum of zeros. Sum of zeros taking single zeros. This is sum of products. This is sum of product of zeros taken two at a time. This is sum of product of zeros taken two zeros at a time, and this is product of zeros. Now let us see some examples. From the given examples of polynomials, let us write the relationships. See, here we have some examples of cubic polynomials. If alpha, beta, gamma are the zeros of the given cubic polynomials, find the values as given in the table. the sum of zeros, the sum of products of zeros taken two at a time, and the product of zeros. We have to write. This is alpha plus beta plus gamma. You know, alpha plus beta plus gamma is equal to minus b by a. And here alpha beta plus beta gamma, this is gamma, plus gamma alpha is equal to c by a. And alpha beta gamma is equal to minus d by a. So in the first polynomial, x cube plus 3x square minus x minus 2. Alpha plus beta plus gamma is equal to minus b by a. So minus b, minus of 3. Minus 3 by a is 1. So minus 3 by 1. This is minus 3. And this one, alpha beta plus beta gamma plus gamma alpha. This is c by a. Here c is minus 1. Minus 1 by 1. This becomes minus 1. Here alpha beta gamma is minus d by a. So minus of minus 2 by 1. This is positive 2. And here the second cubic polynomial is 4x cube plus 8x square minus 6x minus 2. Alpha plus beta plus gamma is equal to minus b by a. Minus b means minus 8 by a. A is 4 here. So minus 8 by 4. This is minus 2. And here alpha beta plus beta gamma plus gamma alpha is equal to c by a. C here is minus 6 by a is 4. So minus 6 by 4. This is minus 3 by 2. And this one alpha beta gamma is equal to minus d by a. So here minus of minus 2 by 4. This is 2 by 4 is equal to 1 by 2. And the third cubic polynomial is x cube plus 4x square minus 5x minus 2. Alpha plus beta plus gamma is equal to minus b by a. Here b is 4. So minus 4 by 1. This is minus 4. Alpha beta plus beta gamma plus gamma alpha is equal to c by a. Here c is minus 5. Minus 5 by a is 1. So minus 5 by 1, that is equal to minus 5. And here alpha beta gamma is equal to minus d by a. Here minus d, that means minus of minus 2 by 1. This becomes positive 2. Then the fourth cubic polynomial is x cube plus 5x square plus 4. Here x term is not written. X term is missing. So the coefficient of x term is 0. We can write it as x cube plus 5x square plus 0x plus 4. Alpha plus beta plus gamma is equal to minus b by a. So it is minus 5 by 1. This is minus 5. Then alpha beta plus beta gamma plus gamma alpha is equal to c by a. C here is 0. This is C. C is 0. So 0 by 1. This is 0. Then alpha, beta, gamma is equal to minus D by A. So D here is 4. So minus 4 by 1. That is minus 4. Thank you. See you in next video.